Hello everyone, I'll be presenting the first part of my policy paper on negative emission technologies. And for this part, I'll be sharing the global trends and applications in the Philippines. The outline of this presentation would include a brief introduction and then global trends in the technology as well as application in the Philippines. This graph shows the annual CO2 emissions in the country, and as you can see, there's a big jump from almost zero in the 1950s to more than 140 million tons of CO2 emissions per year in the year 2019. And take note that this does not include yet the land use change, so the values should be higher when we include the land use change. And actually, this graph is a good indication that we are thriving economically speaking, that we are being industrialized. Although the Philippines is still one of the lowest CO2 emissions one of the lowest country that emits the lowest CO2 emissions per year in terms of per capita. We are at 1.22 tons CO2 per capita, and compared to the US, which is at almost 15 tons CO2 per capita. Our growth in the CO2 emissions is the fastest, one of the fastest in the world, which is 5% growth per year. And there's a strong link with the anthropogenic CO2 emissions with climate change. Unfortunately, some countries will be more exposed than others. For example, the ASEAN in particular have suffered the most from climate change or climate-related events for the past years. And if left unchecked, the global warming may rise up to 4 or 5 degrees Celsius by the 21st century. And as you can see in this figure, the impacts would be falling yield, sea level rise, species extinction, and extreme weather events. Enter negative emission technologies. So negative emission technologies, or NETs, remove carbon dioxide from the atmosphere and transfer it to another environmental component like underground or in the oceans or in living biomass. And in this graph, it shows that first, the business as usual scenario. If we do not have policies in mitigating climate change and reducing our CO2 emissions. And then the other one is the below 2 degrees scenario, which means we are limiting the global warming below 2 degrees by the 21st century. And to do this, we must reduce our CO2 emissions. But in this graph, it also shows that there's a need for negative emissions. So aside from emission reduction, there's also the need for nets. And the focus of this policy paper would be the two nets, which are Biochar, a low technology net, and direct air carbon capture and storage, or DACCS, which is a high technology net. So the reason why I chose these two would be because I want one low technology net and another high technology net, so we can have options. For biochar, CO2 sequestration happens during photosynthesis. And instead of letting the CO2 or methane, CH4, be released to the atmosphere upon decomposition of the biomass, we convert the biomass into biochar or charcoal, and then we store it either in the soil or in construction materials. On the other hand, DACCS uses chemical reactions to capture low concentration CO2 from the atmosphere, and then further uses engineering solutions to store the CO2, usually deep underground. Moving on to the global trends. But first, let me share with you the trends on net zero emissions. So these are the countries that either pledged or proposed in their laws net zero emissions by the mid 21st century. But before that, the countries Suriname and Bhutan already achieved net zero emissions. This means that their CO2 emissions, whatever that they're releasing into the atmosphere, is just being absorbed through their forests. And then for the rest of the countries, we have Sweden, UK, France, Denmark, New Zealand, and Hungary. They all have net zero emissions by law. So in their law, um, they are forced to have net zero emissions by 2050. The other countries, Canada, South Korea, the European Union, Spain, Chile, and Fiji, have net zero emissions proposed in their law. So it's still being proposed, but eventually it will become a law. For these countries, we have Finland, Austria, Iceland, Japan, and many others. They have pledged net zero emissions in their policies. And not just these countries, more countries are joining the bandwagon as we speak. You can see the countries in this website. So they track the net zero pledges. It's not just countries, but big companies as well, such as GM, United Airlines, Shell, HSBC, Google, YKK, and Amazon. They all pledge carbon neutrality by the mid 21st century, so by 2030 to 2050. And they are doing this either by investing in renewable energy or through carbon offsets. What are carbon offsets? So whatever CO2 that these companies are releasing, they are also investing in another projects such as forestation or other negative emission, so that it will result ultimately to net zero emissions. And this is the website which tracks the companies who have pledged net zero carbon by 2040. There are 110 businesses that have pledged net zero emissions by 2040. In terms of DACCS, these countries, Sweden, UK, Denmark, and Japan, all have projects and investments in direct air carbon capture and storage. For example, Sweden has launched project on DACCS, and UK is investing millions of pounds on carbon capture. Denmark will develop cost-effective solutions for DACCS, and Japan will not only promote R&D on photovoltaics, but also on nets and carbon capture and storage. In terms of companies, we have Climeworks from Switzerland and Global Thermostat from the US. They have demonstrated DACCS in small commercial scale plants. So in fact, DACCS is already a demonstrated technology, but only in small commercial scale, not yet in large scale. And there's another company, Heirloom Technologies from the US. It's also developing a novel, cost-effective DACCS, and recently it has gained funding. Now, actually, the technology DACCS has two aspects. We have the direct air carbon capture and then the storage part. So the storage part is usually done through underground or geological storage, and this technology has already been proven in many facilities around the world. So we have 51 carbon capture and storage facilities that are linked to CO2 emissions plants, meaning the carbon capture and storage of these facilities capture high concentration CO2 emissions from flue gas streams. And this is different in a way that in the carbon capture part, because it's easier to capture carbon if it's high concentration, but in the atmosphere it's just 400 ppm, so it takes a higher amount of energy to capture carbon from the atmosphere. Nevertheless, for the storage part, which is compressing the CO2 gas into liquid and then pumping it into the geological storage, it's the same technology. So there is already, we have that technology, and it's storing 96 million tons of CO2 per year. And these carbon capture and storage facilities are located all over the world. We have in the US, South America, Europe, China, and Australia. On the other hand, for the global trends in biochar, it is yet to be demonstrated in large scale. So there are small and pilot scale demonstration, but no large scale demonstration of the technology yet. However, there's a company called Green Asphalt. It has demonstrated in pilot scale applying biochar in construction materials in the following countries. We have Austria, South Africa, and Australia. And there's an existing biochar production plant in Austria. So how does it apply biochar in construction material? So in asphalt, we usually have 85% gravel, 10% filler, and 5% bitumen in the mix. But instead of having 10% filler, 2% of that is being replaced with biochar. And they demonstrated that this mix of asphalt passes the same standard as the normal or regular asphalt. And it's not just in asphalt. Biochar can also be used in building facades, such as in the picture. So it's really nice. And for Europe, the biochar market growth is increasing exponentially. So this graph shows the increase in the market until 2020. And the pictures here show the industrial grade or industrial scale biochar equipment. So we can also have, in the Philippines, we can make our own biochar equipment because relatively the technology is easier to invent or to do. Now let's move on to the application of biochar and DACCS in the Philippines. Well, for the Philippines, we have not yet promised or pledged net zero emissions, but we have pledged 70% conditional emissions reduction by 2030. So what are the conditions? To have international financial aid, and including technology development and technology transfer. And a lot of environmentalists actually criticize this pledge, saying that the Philippines' commitment is not adequate. And there's no currently application of DACCS and biochar in the Philippines. There are no large-scale applications. And there's a study by the Asian Development Bank in 2013 investigating the applicability of DACCS in the country. And they have found out that there's no implementation yet due to technical challenges and the absence of carbon emission reduction policies. Just an update. So in 2020, we still do not have an explicit carbon taxation scheme in place. Nevertheless, We do have other nets in the form of forestation. So we have programs like the um, National Greening Program, and we have the community-based forest management strategies. And these programs also act as negative emission technologies. How can we apply biochar in the Philippines, or for what application? Um, the first and foremost purpose is for climate change mitigation, because we have promised 70% reduction in emissions by 2030. That means we need to avoid around 244 megatons of CO2 emissions, and that's a big number. The problem is we are currently using fossil fuels in our energy mix at 70%, and 31% of that is coming from coal. Okay, so achieving this 244 megaton emission reduction is really a challenge. Although we do have policies like the National Renewable Energy Program and also the Energy Efficiency and Conservation Act. And like I said, we have the forestation programs. I believe that these policies are not enough, and we need policies to implement nets in order to complement our existing policies. Aside from climate change mitigation, biochar can also be used as soil amendment, because it has so many benefits, like improving the soil quality by increasing the fertility. It increases the water holding capacity and provides carbon neutral fuels such as bio-oil and syngas. And we can also add biochar to construction materials like asphalt and use it in buildings, like what is being done globally. As for DACCS, of course, the application is for climate change mitigation, for us to meet our pledge, or our nationally determined contribution in the Paris Agreement. We can either import DACCS, and the benefit of DACCS compared to other nets is that it has a high greenhouse gas removal or carbon dioxide removal potential. In fact, it's the highest GGR potential among the nets. As for the storage, we can tap the Malampaya Oil Reserve. So even if we are on the Pacific Ring of Fire, the Malampaya Oil Reserve will, since it's able to store the oil, it can store the CO2 underground. We can also research on the direct air capture part. So like I said, there are two parts in the technology, and by researching on the direct air capture part, we can sell our technologies in the future. And then in the storage part, we can also use mineral reaction. So we're not just limited in geological storage. We can also explore storage using mineral reaction. So this ends the first part of my presentation for the negative emission technology policy in the Philippines. Thank you very much.